with 0 and negative exponents. And these expressions will get bigger and more involved as we add rules to the list. So the first thing I want you to think about when you look at an expression is how many bases do you see there? 3. One of them's a number, 2 are variables, and all 3 of them actually have their own exponent, okay? So 3 bases, each with an exponent. We don't see all 3 of them, but they're there. So this is a big problem for a lot of people. It's just a careless mistake. No. No. Just like if the negative is not in parentheses, it doesn't get the exponent. What I would suggest you do, if you think you might make this mistake, this only goes with the x. So you might want to take this and say this is actually 4 to the 1, y to the 1, x to the negative 3. Once you can see each exponent, people tend not to mess with the ones they don't need to. So think of a classroom. If you had a problem in your classroom, problem child, you don't remove the whole class, right? You only remove the problem, yes?
Lucas.
Be nice. Okay, which one of these has a problem?
X.
X. So this is like my class. X is the only one with a problem. So X is going to be, that problem is going to be taken care of. So what you're going to do here is this one is going to go, it's going to take the elevator, where the other 2 are going to stay put. Okay? So this one is going to go underneath. Now, you don't see a fraction, but everything is in a fraction if you consider it could be over 1, right? The x with the negative exponent.
Underneath the y?
Underneath both of these. Okay?
Oh.
So this becomes, and you can lose the exponent of 1 if, you know, in your final answer, but that's the only thing that gets moved. So this would be 4y over x to the 3rd.
So we don't need to have
The base with the negative exponent gets moved, everything else stays put.
Yeah, but not negative 3?
Not when it moves. The whole point of moving it is to get rid of the negative on the exponent.
So in our final answer, we don't need to have the y exponents in there?
No.
Okay.
No. Think of it this way. We're upstairs. If I send a student out to Mr. Smith, they go down there, he does an attitude adjustment, they lose their negative attitude, hopefully. Theoretically.
Lucas.
Okay, so the act of moving it from top to bottom or bottom to top gets rid of the negative on the exponent. But you only want to move the things that have the negative exponent. Okay, so this would be simplified. Let's look at another one.
That's all you can do? Like that? That's the final answer?
Yeah, well, we don't know what x and y are, and we're not solving anything because we have no equal sign.
1x or?
Okay, so this one needs an attitude adjustment. It's negative. That is going to move up. What happens when you leave nothing on the bottom? Is that okay? Hmm?
1 goes there?
There's a 1 there, but we don't write anything over 1, right? Not in a simplified answer. So technically, and these are not, we're not doing a switcheroo here. You don't switch. Okay, but x is moving up. You could leave a 1 on the bottom, but that's not totally simplified. We don't need a 1 on the bottom. This technically would be 1 times x to the 4th, I guess, over 1, but are either of these 1s necessary? No. So this is really just x to the 4th. So I'm showing you this, but you can skip to that. Okay, you don't need to do this in between. All right, what if we had
24.
x to the 5th, or x to the negative 5th over y to the 6th? What moves? Let's start there.
Go y.
That's the only one that has a problem, right? So that one's going to move down. And when you have more than one variable together, the general rule of thumb is we do them alphabetically. So that one will move in front. So we have x to the 5th, y to the 6th. But what do I do with the top? Okay, now when the 1 is on the bottom, I don't need it, right? Because that's division by 1. But what if I move everything out of the top? Those are on the bottom.
Do you move y?
No. Y is fine.
You put a 1.
I put a 1. The 1 on top is there as a placeholder. If I take that 1 away, that wouldn't mean the same thing, right?
Yeah.
Because 1/3 is not the same as 3. Okay? You have to have the 1 on top if you remove everything that was on top. All right? You don't need the 1 on the bottom, however. Okay? So this would be simplified. Okay, so let's look at one more of these. S. So you should look at the big picture, determine which one or which ones are actually problems.
That's 7.
Is
That's
this
a 7s.
7s to the negative 4 r to the 2nd?
Goodness, Lucas.
So what is the problem or problems?
That's -4.
This is the only one that's an issue, right?
Yeah.
So 7 and r squared. In fact, 7 has its own exponent of 1. 7 is not a package deal with s. Okay, that's why I say you might want to put the 1 in so you don't mistakenly move it. So the 7 and the r squared are going to stay right where they are. S to the negative 4th is going to take the elevator and move down, and instead of -4, it will become +4. Okay.
She has to go.
Go. Well, that's what they're for. Okay, last thing we need to do is evaluating.